The system of water supply in a city is a complex and essential infrastructure that ensures the delivery of clean and safe water to homes, businesses, and public facilities. This system involves multiple stages, including the sourcing, treatment, distribution, and maintenance of water. Understanding each component of this system provides insight into the intricate processes that keep urban areas supplied with one of life's most critical resources. Water supply begins with sourcing, where water is obtained from various natural sources such as rivers, lakes, reservoirs, and underground aquifers. The choice of source depends on factors like availability, quality, and proximity to the city. Surface water sources like rivers and lakes are often more accessible but may require extensive treatment due to contamination from agricultural runoff, industrial discharges, and urban pollutants. Groundwater, drawn from wells, is generally cleaner but may be limited in quantity and susceptible to over-extraction. Once the water is sourced, it must undergo treatment to ensure it is safe for consumption. Water treatment plants are equipped with multiple processes designed to remove contaminants and pathogens. The initial stage of treatment is coagulation and flocculation, where chemicals are added to the water to bind with particles and form larger clusters called flocks. These flocks are then removed through sedimentation, allowing them to settle at the bottom of a tank from where they can be easily extracted. The next step is filtration, which involves passing the water through layers of sand, gravel, and activated carbon to remove smaller particles and impurities. This process is crucial for eliminating suspended solids, bacteria, and viruses. Activated carbon filters are particularly effective in removing organic compounds and improving the taste and odor of the water. After filtration, the water undergoes disinfection to kill any remaining pathogens. Chlorination is the most common method, where chlorine or chlorine compounds are added to the water. Chlorine is highly effective against bacteria and viruses, ensuring the water remains safe as it travels through the distribution system. Other disinfection methods include ultraviolet UV light and ozone treatment, which are also effective but may be more costly or require specific conditions to work efficiently. With the water now treated and safe, it is stored in large reservoirs or storage tanks before being distributed. These storage facilities ensure a steady supply of water even during peak demand periods or emergencies. They also provide the necessary pressure to push water through the distribution network. The distribution system is an extensive network of pipes, pumps, and valves that deliver water to consumers. The network starts with large-diameter transmission mains that carry water from treatment plants to various parts of the city. From these mains, smaller distribution mains and service lines branch out, reaching individual buildings and homes. The design and maintenance of this network are critical to ensuring efficient water delivery and minimizing losses due to leaks or breaks. Pumps are used to maintain water pressure within the distribution system. In areas with varying elevations, booster pumps are installed to ensure consistent pressure and flow. These pumps are strategically placed throughout the network to overcome gravity and friction losses, allowing water to reach even the highest points in the city. Valves play a crucial role in controlling the flow of water within the distribution system. Gate valves, butterfly valves, and pressure-reducing valves are commonly used to isolate sections of the network for maintenance, regulate pressure, and control the direction of flow. Proper valve management ensures the system's reliability and flexibility in responding to emergencies or changes in demand. In addition to delivering water, the distribution system must also protect against contamination. Cross-connection control programs are implemented to prevent backflow, where contaminated water could flow back into the clean water supply. This involves installing backflow prevention devices at critical points within the network and conducting regular inspections and testing to ensure their effectiveness. Metering is another important aspect of water distribution, as it allows for the accurate measurement of water usage by consumers. Water meters are installed at individual properties to record consumption, which is then used for billing purposes. Metering also helps identify leaks and inefficiencies within the system, enabling timely repairs and conservation efforts. Maintenance and monitoring are continuous processes within the water supply system. Regular inspections, cleaning, and repairs are necessary to keep the infrastructure in good condition and prevent issues such as leaks, blockages, or contamination. Advanced technologies, such as remote sensors and automated control systems, are increasingly being used to monitor the network in real time, providing data on flow rates, pressure, and water quality. This information allows for proactive maintenance and rapid response to any problems that arise. Water quality testing is a critical component of maintaining a safe water supply. Samples are regularly taken from various points within the distribution system and analyzed for contaminants, including bacteria, chemicals, and heavy metals. This ensures that the water meets regulatory standards and is safe for consumption. Public health agencies and water utilities work together to monitor and address any potential threats to water quality. Public education and outreach are also important aspects of a city's water supply system. Informing residents about water conservation practices, proper disposal of hazardous materials, and the importance of protecting water sources helps reduce demand and prevent contamination. Community engagement initiatives, such as water-saving incentive programs and educational workshops, encourage responsible water use and foster a sense of stewardship among citizens. The water supply system must also be resilient to emergencies and natural disasters. Contingency plans and emergency response protocols are developed to address situations such as power outages, equipment failures, or contamination events. Backup power supplies, redundant systems, and emergency water sources are put in place to ensure continuity of service during crises. In recent years, the impacts of climate change have posed additional challenges to water supply systems. Changes in precipitation patterns, increased frequency of extreme weather events, and rising temperatures can affect water availability and quality. And water utilities are adapting by implementing strategies such as water reuse, improved storage capacity, and investment in resilient infrastructure to cope with these challenges. Sustainability is a growing focus within the water supply industry. Efforts to reduce water loss through leak detection and repair, promote water-efficient technologies, and develop alternative water sources are critical for ensuring a reliable supply for future generations. Innovations such as desalination, rainwater harvesting, and wastewater recycling are being explored and integrated into water management practices to enhance sustainability. The financial aspects of managing a city's water supply system are also significant. Funding for infrastructure development, maintenance, and upgrades often comes from a combination of government grants, loans, and revenue generated from water usage fees. Ensuring affordability while covering the costs of providing high-quality water services is a balancing act that requires careful planning and efficient resource management. In summary, the system of water supply in a city involves a series of interconnected processes that ensure the delivery of clean, safe water to the population. From sourcing and treatment to distribution and maintenance, each stage plays a vital role in maintaining a reliable and sustainable water supply. The integration of advanced technologies, proactive management, and community engagement are essential for addressing the challenges of urban water supply and ensuring its resilience for the future. This intricate network underscores the importance of water as a fundamental resource and the need for ongoing investment and innovation to meet the demands of growing urban populations.